Alright guys, so welcome back to another video lesson. Today we're going to be solving equations where the variables on both sides of the equal sign. Today's goal is very simple. We're going to move all the variables to either the left side or the right side, and all your numbers, your constant on the left side or the right side on the other side, so we can solve it like a regular two-step or multi-step equation. It's going to be a little bit difficult at first, so remember to practice your whisk. So watch the video, pause it, rewind it, fast forward it, summarize it at the end, make up your own example, write down some of my examples, and then I want you to write down any questions you have for me to answer in class. So let's begin. So the first equation, if you look on the screen, you see that you have 7 plus 3h is equal to negative 1 minus 5h. You can quickly see that you have positive 3h on the left-hand side of the screen and then a negative 5h on the right hand side of the equation. You also have a positive 7 on the left side and a negative 1 on the right hand side. So really, it looks a little bit confusing. But don't worry, don't panic. Choose a side where you want to move the variable. The general rule of thumb for me is if you guys want to, you can move all the variables to the left-hand side and then all your consonants or your numbers to the right-hand side. If you reverse it, you move all the numbers to the left-hand side and all your variables to the right-hand side of the equal sign. It will be the same at the end. Just remember that in this expression right here, or this equation, you have a positive 7. You also have a positive 3h, a negative 5h, and also a negative 1. So I want you to think about it in terms of individual terms instead of a long chain of addition and subtraction. So you can quickly see that I have the blue matched up together on both sides of the equal sign, and I also have the red matched up on both sides of the equal sign. So the goal for today is to move all your variables on one side and all your numbers on the other side. But first I'm going to show you how to model this. So here's the model. Positive 7 plus 3h is equal to negative 1 minus 5h. Remember that when I have a green bar, it means I have a positive variable. When I have a red bar, it's a negative variable. A white square is positive 1, a red square is negative 1. So I've already went ahead and modeled it for you on the screen. So here I have positive 7 plus 3h is equal to negative 1 minus 5h. So what I need to do is I need to move all of these red ones right here, red negative 5h, over to the other side. But what I know about math is if I want to move it to the other side of the equal sign, across the equal sign, I have to do the inverse operation. So I can't really, remember we don't really subtract in math, we always add either positive or negative. So in order to move these 5 red bars over here, I need to add 5 green bars to both sides. Okay, so I'm going to quickly do that. So there's 1, 2, 3, 4, 5. And what I know now that if I add 5 green bars to the right hand side, I better add 5 green bars to the other side of the equation to keep it balanced. So 1, 2, 3, 4, 5. So now I'm going to go ahead and cancel everything that doesn't cancel. So I know that if I have 5 red bars with 5 green bars, you can see right here, 1, 2, 3, 4, 5. These bars right here, they cancel out, so they disappear. So all I have left on the right hand side is negative 1. On the left hand side of the equal sign, now I have 1, 2, 3, 4, 5, 6, 7, 8 green bars. So in other words, I have a positive 8h. And I have positive 7 plus 8h is equal to negative 1. Now I just have a regular two-step equation. So again, if I want to move, since I move all my variables to the left-hand side, I need to get this positive 7 over to this side. And remember in math, in order to cross that equal sign, we have to do the inverse. So instead of adding 7 to both sides, I'm going to go ahead and add negative 7 to both sides of my equations to cancel out the left-hand side. So there's 1, 2, 3, 4, 5, 6, 7. So since I added 7 red ones, or negative 7 to this side, I better add it to this side. So 1, 2, 3, 4, 5, 6, 7. Okay, so make sure I added 7. I can quickly check. 1, 2, 3, 4, 5, 6, 7, and here's my original one. And now I'm going to go and cancel everything that cancels. So this positive and negative 7 creates a 7, 0 pairs. So that's gone. That's gone. That's gone. So all I have left is, let's write our expression. I have positive 8h is equal to negative 8. And now we just solve for h. And in order to do that, divide both sides by positive 8. And I get h is equal to, I know that a negative divided by a positive is negative 1. If you clearly look at the model, I'm going to break this up into even groups. So I have positive 8 groups, and in each group there's one red tile. And that's how you solve using the model. But really, the first question you should ask is, how do I get this right here over to the other side? And remember that in order to get to the other side of the equal sign, I need to do the opposite. So if that model problem was a little bit long for you and you want to go straight to just the procedural part, go ahead and fast forward. Let's look at another problem. So I have 8x plus 4 is equal to 15 minus 3x. So the first thing you want to do is you want to collect all the stuff with the variables on one side of the equation to the other side. And remember that in order to get to the other side of the equal sign, it doesn't matter if it's left or right of the equal sign, you have to do the opposite of whatever the sign is. So in this case, I wrote collect all the stuff with the variables on one side by adding or subtracting things on both sides. Okay, so right now, go ahead and decide where do you want to move this negative or positive 8x. So I'm going to go ahead and circle similar terms. I know that 8x and that negative 3x is the same. I also know that this positive 4 and this positive 15 are also the same. So I need to move all my variables to one side and all my constant on the other side. So combine like terms. So let's go ahead. And then remember, you just solve it by undoing your orders operation. In other words, some teacher calls submit. I like to call it unwrapping, and then we solve for x, and then we check our answer. So going back, first thing you're going to do, I'm going to go ahead and move this negative 3x across the equal sign to the other side by doing its inverse. Well, the inverse of negative 3x is positive 3x. So I need to have positive 3x at both sides. So I have 8x plus 4 plus 3x from the other side is equal to 15 minus 3x plus 3x. Why did I write it out longhand? Because I want to show you that this right here is just like with the model, cancels out. This positive 3x and this 8x right here combined together to give me 11x, or in other words 11 individual positive variable green bars. So I have 11x plus 4 is equal to 15. Okay, I already combined like terms. So now I have 11x plus 4 is equal to 15. In order to unwrap this, undo this, I know that the first thing that happens I'm going to quickly draw my table. The first thing that happens to my x is being multiplied by 11 and then being increased by 4. The result is 15. So immediately, so this is wrap, this is undo. So just like we practiced a couple weeks ago, 15, the opposite of adding 4, minus 4. The opposite of multiplying by 11, divide by 11, and then I take my results and I just run it up the undo column. So 11 minus 4 is 11. 11 divided by 11 is 1. So my final answer is 1. X is equal to 1. Now is a very important step. You need to take your variable that you just solved, the solution that you just found, and you need to take it back all the way up. And you need to substitute it back into the original equation, add it as is. So since x is equal to 1, let's check. 8 times 1 plus 4 should be the same as 15 minus 3 times 1. I know that 8 times 1 is 8 plus 4. 15 minus 3 times 1 is 3, so I really get 12 is equal to 12. Yes, my solution checks out. Okay, last one of the day. Practice with these steps. I have 6w plus 4 is equal to 2 times the quantity of w plus 1. So what should we do first? Just like we did the last couple of days, the first thing I want to do is mess with the distributive property right here. So what I need to do is I need to distribute the 2. So in other words, I'm going to write this out longhand. I have 6w plus 4 is equal to 2 groups of w plus 1, w plus 1. I have 2 groups of w plus 1. Okay, so what I need to do now is just bring the 6w plus 4 down, and I need to combine these like terms right here. I get 2w plus 2. Okay, that's what that distributive property really means. And in the shorthand way is to do what's called I call it the double rainbow, but it's really called the distributive property. So I get 6w plus 4 is equal to 2 times w is 2w, 2 times 1 is positive 2. So now I have 2w over here, 6w over here. I know that I need to combine this with this. Go ahead and change color for you. And this positive 4 with this negative 2. So I'm going to go ahead and move this positive 2w across the equal sign to the other side. And what is the rule for moving anything from one side of the equal sign to the other? You have to do the inverse operation. So the inverse of positive 2w is minus 2w. Minus 2w. Or add negative 2w. Both of those are the same. So right away, I know this cancels out. I know that 6w minus 2w is 4w. Bring the positive 4 down is equal to positive 2. Next, I need to get this 4 across the equal sign by doing its inverse. The inverse of positive 4 is negative 4. I'm going to add negative 4 or minus 4 from both sides. I get 4w is equal to positive 2 minus 4 is equal to negative 2. So I get 4w is equal to negative 2. And what do we do here? To solve for w, I divide both sides by 4. And this one, I get w is equal to negative 1/2. In this case, I get a fraction. So I really have one more example, and this last example is kind of like the last one, but this time the number outside of the outside the parentheses is a negative. So I want just watch what I do real quick. I know that 6w plus 4 on the left hand side, I can't really do anything with it right now. I'm just going to write it. But what I'm going to do is I'm going to go ahead and take this negative 2 outside and distribute everything to the inside. So I know that negative 2 times w is negative 2w's. I know that negative 2 times positive 1 is a negative 2. And then from there, just like the last couple examples, what I need to do is that I need to get this negative 2w over to the left side with this 6w by doing its inverse operation. So the inverse operation of negative 2 is positive 2w. Okay, so the inverse of, again, negative 2 is 2w plus 2w. I quickly can see that this cancels out, and I get 6w plus 2w is equal to 8w, and then I'm going to drop everything that doesn't cancel out. So 8w plus 4 is equal to negative 2. Here, I can do the undo table real quick. I know that the first thing that happens to w is it's being multiplied by 8. I know the next thing is it is increased by 4. I know that the result is negative 2. So what I'm going to do is go ahead and do the inverse of, do the undo column, which is the opposite of positive 4, or adding 4 is minus 4. The opposite of multiplying by 8 is dividing by 8. Take negative 2, and I'm going to run it to each of those. So I get 2 minus 4 is negative 6, and then negative 6 divided by 8 is negative 6/8. You can leave it in its fraction form. Or so negative 6/8 is reduced down to, I know that a common denominator or common factor between 6 and 8 is 2, so negative 6 divided by 2 is negative 3, and positive 8 divided by 2 is 4. So my final answer is w is equal to negative 3/4. Okay, so that's how you mess with negatives when it is part of the distributive property. All right, I'll see you guys in class.